Alrighty, so today I will definitely finish the OOP review, and the last topic would be static variables, and also how you should really use it properly. That's something we'll talk about. And as usual, let's have some quick reminders about what you should be aware of. Quite a bit for this week, so let's watch out. So your lab number 1 has been released. Tomorrow I'll be attending your lab sessions in the morning and the afternoon. Yeah, so tomorrow I'll be attending both sessions for the lab, and you can ask me questions. I might do some little demo as a convention just to get you motivated and get some useful stuff for you. And then your mock-up programming test is going to be this Friday, either 5 p.m. or 6 p.m. If you want to attend it but you haven't registered yet, please do so. There is a link from my e-class announcement from Friday. You have to register before you can attend. But seats should be almost guaranteed. We should be fine. And for your written test number 1, it's going to be next Wednesday. Not the coming Wednesday, but next week, in about a week time. So tomorrow, I will give you the precise guide about what you should really expect for written test number 1. I will also give you some example questions. I'm thinking about maybe for both section E and F, we can have some optional review session, maybe just to answer your questions about written test 1. For those of you who might find it useful, then you can attend over Zoom, not in person. I don't really have that much time left on Monday, most likely around 12 noon, most likely. But I'll record it. If you can attend, feel free. If your friend can attend, ask them to ask questions for you, something like that. I will announce the detail to you about a review session. Hopefully that will help. And for your programming test number 1, it's going to be after the written test 1, of course. But I think it's really good to get prepared earlier than later. And the best preparation would be before Friday's mock-up test, try to treat it as if it's the actual test. Review all the stuff you did for Lab 0, Part 1, and Part 2. Make sure you really understand the programming pattern very well. And then I would suggest try to make progress on Lab 1 as much as you can. It will also help. And one thing administrative. If you go to the lecture site, and then there's one document I added, nothing surprising, but let me just show you. It's important information. So underneath the course syllabus, there's one document here just about attendance rules. Nothing new here, basically just based on our experience from that trial attendance check we did earlier. So starting from this week, we're going to do real attendance checks, right? Especially for those of you who might have issue before about the, getting, joining the course, you may want to look into the tips given by iClicker about refreshing your geographic location. It might help, but we'll see. I do have the attendance sheet over here, and if we do attendance check today, then in the worst case, it will still be check-in. So don't worry too much, but it will be nice to just get it done automatically. Let's have some recap, and then you can ask me questions about the course contents. So what did we talk about last time? Okay, let's see. Actually, if you ask me about what did I teach last time, I think only one single thing, which is the marriage example, right? But that example there really exemplifies so many useful theories and practical stuff that you should really watch out for. Right? We'll talk about some reassignments of the array, and then we talk about aliasing path, right? About different paths that will simply refer to the same objects. I would say aliasing path itself are not really difficult. What's really difficult is to really get to draw the diagrams like this in the first place. If you can, most likely I will just give you a piece of Java code and then ask you, give me the aliasing path. In that way, once you can really draw this diagram, as we have been doing that many times in the class, then you should be able to answer about aliasing path, like here. Right? So that'll be my tip for you. And we talk about reference type return values, very useful. And you also want to make sure you read the written notes about what if the return value is rather than point, it can be point array. Get points in Trojan 1. That's the method in the written notes. Make sure you understand that method as well. Important. And we talk about anonymous objects, especially how can you combine anonymous objects together with helper methods. You can greatly simplify your code structure. I think it's a very good software engineering practice to apply. And you should really try applying them, maybe starting from your lab number 1. And for all the labs onwards. Should you do anonymous objects and helper methods in the programming test? I would say it's up to you, but time will be your worst enemy. So if you think it will take time for you to rewrite all your code by using anonymous object helper method, I would say don't bother for programming test because you really want to use up all the time that you have. All right, so we'll talk about this particular method for Mary over here. Go over every detail I spoke about. And we also review a bit about logical operators. Right? I also gave you some exercise to really do. The answer should be quite straightforward, but if you got any question about it, reach out to me, and then we can discuss. Right? So logical operator is also very important, even though it's not strictly OO, it's part of the procedural Java, but you also need it for your coding. All right, so that's about the end of last time. Any question? Any part you want me to clarify? Any part you want me to repeat? Okay, awesome. So why don't we talk about some little bit new stuff for the review? Maybe you know them already. If you don't know, that's okay. Now will be time to learn. Let's talk about static variables. That'll be the last topic for the review slides. Slide 75. Okay? What's really static variable? Strictly speaking, static variable doesn't belong to object-oriented programming paradigm because it's really the concept that belongs to so-called global context, which is something I will contrast for you. Think about attributes that we spoke about before. It's really OO because we are saying that for every object of the same template, they have their own copy of the attribute. For example, every person object has the attribute age. Every person object has different age copy, right? Different age value. On the other hand, there might be some occasion you may want to use something that's global, a single copy, to be shared by all the instances of the same kind. So that will be the usage scenario that we want to look after as well. That's something we'll see. And before we see the actual static solution, why don't we look at what if we are trying to solve a particular problem without static? What's going to happen? Let's see. And I would like you to please look at this piece of code just for 1 minute. Just get yourself used to what it is trying to do. How about this? These two. The box over here is a definition for the template. The box underneath tells you how to use them. All right, take a look for 1 minute, and then we'll discuss. All right, another 20 seconds. I can tell you my conclusion right away, but you may want to think about why. This is not a good design. It might work in Java programmatically, but it's not a good design. One angle to think about it is, what if you are the user of the account class? So this would be some user-oriented code you have to write in order to use the account class. What's really bad about it? Think in that direction. And then I might take your input since you raised your hand. Okay, how about another 10 seconds, right? Okay, assuming that everybody is at least familiar with the code, and so we can talk about it. And a similar code structure is going to sustain between without a static when we versus when we move on to the actual solution using static. Similar. Yes. Why would you think that's bad?
So when you go to initialize an object there, the ID is not the same when you do like say for the second one count two, like it's supposed to be one.
That's
So they both share the same ID.
That's absolutely correct. I appreciate the answer. And your classmate said something exactly right. Let's now confirm and also write it down. This design here, I want you to notice several things over here. Number one, if you look at the parameter design for the constructor, you can see the parameter here, account. There is one parameter here that's explicit. Every time as a user of the account class, if I want to create an account object, I have to explicitly pass a value for the ID. And the ID better be not being used before, because ID is supposed to be unique, not duplicated, right? So this is some explicit parameter, presumably not duplicated. Not duplicated. Let's take a look at what I mean by not duplicated. Now, of course, for the rest of the class, you can see it's pretty straightforward. For the constructor, it's simply assign ID to ID, owner to owner. And you should not be very convinced why we have to use the this keyword, right, to get rid of, to really break through the shadowing, right? That's something we spoke about before. So we are creating two objects here of type account. So here, me as a user, I have to make sure when I pass these two arguments, they better be not duplicated, right? 1 and 2. In this case, I'm good. As your classmate correctly pointed out, there's no Java obligation for me to do so. Let's say if I simply change this one from 2 to 1, nothing is going to happen. Just tell me something's wrong. Nothing. All right? So there are two things I would like to say. So these are the two arguments that's going to be passed into ID. Number one, the burden is on the user. On the user of account to specify unique ID, not duplicate ID. Whenever you're trying to design a template or a class, you really want to make its usage for the potential user as simple as possible. All right? Anything that can be somehow turned into internal, you should be turned into internal. You will see what I mean by turning internal. And number two, not a compilation error. So I'm talking about compilation error is because I tell you to always look out for on the Eclipse if the project will have some red cross. But this one here isn't going to cause any red cross. No. Not a compilation error. If the IDs are duplicated. So for example, if I say rather than 2, I simply put 1. Apparently, there are two users, Jim and Jeremy. They have the same ID. Logically, that's wrong. Java is not going to complain to me. That's bad. Of course, you're going to fail this particular test, right? This test is to ensure every account's ID should be different. It's going to fail this particular test, of course. All right, any question about this bad solution? Every time we are trying to learn about a good solution, I think it's really important to get motivated first why we need that good solution. But then we get to appreciate how bad the bad solution is. Right? It's really something I want you to both understand. Any question about this before I move on to the right solution using static? All right, so you can also think about it, right? If you don't get 100%, think about it. That's why I'm recording the lecture, so you can revisit whenever you want to. Before I present to you the actual solution, let's now get very clear about static versus non-static attributes or variables. And then I already make available the source code to you. I'll show you where to find them. If you go to the lecture site, you will see here under the code section here, you will see static versus non-static. So that's the code I'm going to present. I will highly recommend, once I present to you how the code works on the paper, you should really try them out on Eclipse as well. And feel free to modify the static keyword in whatever way you like and try to convince yourself the corresponding output makes sense. For example, you may want to change something static into non-static or vice versa. Okay? Let's now take a look at the code. All right, let's now only focus on this simple counter class. And for now, please just disregard this part here. Okay? Let's only focus on this part. So we have a class called counter. And we have two variables, or seem to be attributes. But they are a little bit different. Because you can see one is declared with static, the other one, no static. Agree? At least syntactically, you can see the difference, right? So let's now annotate to understand. when I have something like this without a static, it's so-called non-static variable. This will be non-static. Or we can simply say they are attributes. You don't really say something that's static attribute. You don't say that. Whenever you say attributes, you really mean they are non-static. Okay? But you can say they are non-static variable at a class level. The other one, where you can see the obvious syntactic addition here, which is static. Over here, this is static variable. Or you can think about they're more like a global variable here. At least that's what you should really remember yourself about. By declaring a variable being non-static versus static, what do they mean immediately? And let's say a little bit more. For non-static variable, this is what we said earlier. Star, okay, I'll put it here. That means each instance or objects of the counter has its own copy. That's why we said something like instance-specific value. So they got instance-specific value for that. Right? Instance-specific is something you want to recall yourself. All right? The second one is a static. All right? Let's now compare them right away. Okay, I would say star, star over here. What about static? All instances of counter, apparently, share the same copy. And you just say they are just global. Again, that's why we call it global variable. Whenever you talk about anything that's kind of a global, that's really shared by all the objects, it's not strictly OO, but it's good to kind of use them as well. You know, you definitely find some useful scenario, like creating some IDs. All right, and I'll talk about tracing when I get to the user code in just a moment. But let's now take a look at here. Okay, so we got another thing to say. Whenever you got something that's static, because it's supposed to be global, you will normally do initialization right away. Okay. This is initialization. On the other hand, for instance-specific attribute value here, you normally do not initialize that right away in the same line. You normally do that in the constructor. Okay? So here, you only initialize the attribute here. So you will only initialize non-static variables or the attributes in the constructor. All right, let me say it again. For global variable, the convention is you initialize them right away in the same line. But for instance-specific local copy here, you don't really do that. You only do that when you first create the instance using the constructor. Okay? That's also another convention you would like to follow. That's what other programmers do. And we got some easy accessor, getting the local value, and also change the local value by 1, plus plus. I'm pretty sure you know what this means, right? That's actually part of the programming pattern. And this one here, we just want to increment the global, G++. Okay? So you can increment either the local or the global variable as you wish. Any question about this simple class over here? And we're going to see some simple tester code to see exactly how to trace the difference between non-static versus static. Yes?
I know like with non-static values, they are like usually getting the default values by default, right? Like, I mean, 0 for ints and like different for other variables. But for this one, is it also like initialized by default to 0?
For the global or for the,
global.
yes, okay, good. The question goes like this. Let me summarize its point. Let's say this. When we talk about non-static over here, right? That's something we learned earlier. You are supposed to initialize the non-static attributes in the constructor. For those attributes you do not explicitly initialize, they will just have their default values. In this case, for example, L, if I don't initialize that to be 0 explicitly, you will get 0 anyway. That's for non-static. That's something we know. For the global, it's kind of similar in the following sense. Let's say I don't really initialize the static over here. Let's say I don't do that. I don't initialize it. In that way, the G being integer will still be initialized into its default value, 0. But not exactly in the constructor. Because as far as the static variable is concerned, you don't really need to create an instance in order to access the static variable. That's something I'll explain in just a moment. Okay? But let me just write it down, just in case you're interested. Okay, what I can say here is here. If not, initialize in the same line. Like here, right, in the same line. It will be initialized to default value by some other mechanism, which we don't really see. That's kind of behind the scene, okay? To default value. However, not by constructor. Constructor are only supposed to initialize non-static variables. All right. Let's now take a look on this piece of code over here. The idea would be we want to create two counter objects over here, C1 and C2, and then we want to figure out the values for the local and the global, and then we want to increment the local and global and see their values again. That's what we want to do, right? That's a code structure. Let's do one by one. I would say, whenever you try to trace code like this, if you know that there is certain static variable and you know about its default value or its initial value, you want to do that first, okay? Static variable, there's only one single copy. It's a global one to be shared. The way I would draw it goes like this. You might say, I set aside for the class called counter. Right, counter here. And then I'm going to have this global variable, G. I will put a star over here just to remind myself. It really means static. Okay? You can put any symbol you like. It's only for me to be reminded that G is not an instance-specific value. It's a global one. All right, so here, what I really meant here is it is static. And it is initialized to be 0, right? So I'll put 0 over here, the value. And you shouldn't really confuse yourself by having some arrow pointing to here. No, not that way. Because whenever you got arrow, that means there's certain objects over here, but it's not an object. It's a placeholder for this particular single copy of static variable to be shared, okay? Once we have done this, which corresponds to this line here, let's now try to trace these two lines and see what happened. Okay? Line number 1. C1, I'm going to say C1 is going to point to a counter object over here. And now, how many rows should I have for this particular box? It depends on how many non-static variable I have. In this case, only one. This G here should not appear over here, right? Only the non-static one. So that'll be L, and then according to the constructor for the counter, it's going to be 0. Agree? So what you want to understand is this 0 here comes from its initial value here. This 0 here comes from the initial value here. Different, even though they happen to be the same value, right? And the next one, let's now get C2. C2, is going to be very similar to C1. Counter. Local. And then, similarly, it's going to execute this line of code again, get 0. Are we okay so far? So now you can really see the difference between non-static versus static. For non-static, you can see we got instance-specific value, separate copies. If I modify the value here, it's not going to impact here, and vice versa. If I modify the value over here, somehow it's going to be visible to both objects. A little bit like aliasing, but I'd rather don't really confuse it with the word aliasing because there's no reference variable here about aliasing. But you can think about it that way. It's more like an informal analogy. Okay? Again, instance-specific value for the non-static variable, L. This will be global, static. Okay? And let's answer some easy question. What is C1.getLocal? 0, right? C1.getLocal. C2.getLocal. Here, right? 0 here. Don't worry, easy question. I can answer it to myself. But if you got any objection, let me know. Okay? And then we want to know about what's C1.global. This one's interesting. Think about it in this way. To really reference static variable, I'll put it here. To reference a static variable. In Java or in any OOP, you do not really need a context objects because it's global. So all you do is the syntax goes like this: class name dot variable name. One example could be the variable name for the static will be G. And the class name will be counter. So to really show your understanding about static, you would say counter.g. That's how you refer to it. Okay, just a class name dot variable name. You do not need the context objects. No need of the context objects. However, when you see lines like this, C1.g, C2.g, if you try this in Eclipse, Eclipse is not going to report any error. However, it's going to tell you with some yellow underline to say there's some warning to you. Whenever you're trying to access the global or static variable, you are supposed to access it from the class level, like a counter.g. But if you try C1.g, informally you can think about as far as C1 is concerned, what's from its angle the value of the global. And when I say C2.g, what's really the global value as from C2's angle? Okay, it's okay because Eclipse doesn't really give you an error. But you should really know that this kind of reference is going to give you some warning because whenever you want to refer to static variable, you better use class name dot variable name. That's the lesson. Okay. So these two over here compiles by warnings. All right. And now let's see what C1.g and C2.g. So we have C1.g. Basically, we're referring to the G here because the global variable is shared by all the instances. C1.g should be 0, C2.g also 0, the same copy we're referring to. Okay? 0 and 0. Are we okay so far? Not too complicated, right? Okay. Now the conceivable thing to do is to change something. Why don't I do this? When I say C1, let me just number them so you can see exactly where we are. 1, 2, 3, and 4. Okay, 4 updates I would like to do. Just before I start annotating my diagram, can you just imagine yourself, how is the diagram going to be changed after 1, 2, 3, and 4? All right, think about it. Should you touch the instance-specific copy? or should you touch the global copy, right? That one shouldn't be too difficult, but I'll let you think about it. Okay, let's start with the first one. C1.increment local. So increment local here, and this is going to be replaced by C1. So C1.L should be incremented. C1.L should be incremented from 0 to 1. That's number 1. At this point, you can see that changing this copy here does not impact this copy. So this one remains to be 0, right? So they are not shared for the non-static variable. The second one, if I say C2.increment local here, so let me still use purple, that's fine. Number 2, right? So I'm going to execute this the second time, but now this will be replaced by C2. So C2.L. C2.L is here incremented from 0 to 1. That's step number 2. All right? The interesting bit is going to be the next 2 lines. What about this one here? C1.increment global. That one there basically is going to execute this one here. That one there, say G++. So here there are 2 different ways to write it. If it's a this.G++, that's okay, but it's going to give you warning for the same reason I mentioned earlier. Because you're trying to access to the static variable using context objects. It's not recommended. Or you can say counter.G++. That's going to work. Right? You can try both. Now, if I say C1.increment global, it's going to update this copy over here, 1. After this point, if I ask you about what's C1.G, what will be the value? 1. C2.G, also 1, right? Let's try that right away. So if I say C1.G is going to give you 1, C2.G is also give you 1, right? These 2, all good. Final line. How about blue? Increment global for the second time, right? So I'm going to say G++ increment, from 1 to 2. Now, if I say C1.G, C2.G, what should that be? 2, right? I think that's all you need to know between the difference of static versus non-static. Either it's a copy to be shared by all the instances, in which case you use static, or it's a copy that's owned by each individual object, not shared, that'll be non-static. You want to understand this principle first, because in the next 3 examples I'm going to show to you, I want to give you the idea that if you use a static properly, that's good. If you somehow declare something as static where non-static should be the correct solution, you're going to get some funny behavior. That's something we'll see. Yes?
Declare the counter class, but we never make an object out of it. Does any memory get allocated for this?
Indeed. Okay, the question was like this. Good question. The question was, I said here for the static variable G here, there's going to be a separate box over here for that. So let's say I never create any instances of counter. So I never occupy memory like this. Will this still occupy some memory? Indeed. So there will be some integer space in the memory that's going to be allocated. Where it is, we don't know. That's okay. We don't need to worry. All right. All right, guys, any question about this? Not too bad, huh? All right, let's now try 3 different examples. The first example here, I want to give you the correct solution. Remember, we spoke about this bad solution where we got non-static attributes only. But now, by introducing something that's static, we can have a much better solution, which means we are not going to burden the user. Also, we can be sure we don't have any duplicate ID. How nice. Let's take a look. That'll be the solution. You can see here, why don't you take a look at that for 1 minute? And then I do have some interesting question from the morning session. I'm going to mention the answer to you as well. It's a very good one for us to run through. But let's understand this one first, one step at a time. All right. What I highlighted in yellow are the new changes compared with the original solution using non-static variables only. Okay? So now there are three things we kind of changed from the previous solution. Number one, we introduced a new static global variable, and the initial value, we just make it 1. You can make it any value you like, depending on what you want, right? And then ID and owner, the same, right? Non-static and non-static. And now for the constructor, you can see some change right away. There's only one parameter. Compare with, we used to have 1 and 2 parameters. So that ID is gone. So no more burden for the user right away. All right? Let's now put it down. So what I want to say here is you can see as far as the parameters for account is concerned, now the parameter list does not include the ID anymore. The parameter list not including the ID. That means not the burden of the user anymore. That's something you want to notice right away. Right? It's more like a design issue over here. Because we're going to manage the static counter internally. When I say internally, I really meant it's private. So users outside the account class, they cannot get access to it. So you should really make this private. And in the constructor over here, we're going to trace it together. So the idea would be, let this instance specific value, which is non-static, let it copy the current value for the global. And then make sure you increment the global value so that the next account constructor call can make use of this updated value. And then assign the owner. So I want you to pay attention to these two lines. These two. But we're going to understand these two lines by just using some example. We're going to walk through some example. And then I have some question for you. But let's trace them together first. Let's say we got line number 1. We're going to create ACC1 of type account. And we don't pass ID anymore as a user. We just pass the name, Jim. ACC1 is pointing to some account objects over here. And now you have a decision to make. What attributes or non-static variables should you put for the account? How many should you put as far as the template definition is concerned? How many? 1, 2, 3, or something else? Okay, if you said no, that's a good sign. How many? You. Yes. 1? Which one? The owner? How about ID? You can see ID here is also non-static, right? So that one should be there too, right? All the non-static one, okay? So we got ID here, and we got owner here. Both of them, all right? And let me just copy this object here so I can make use of it. And of course, if you forgot, like me, you just got to remember to do the following. You have to make sure every time before you start tracing this particular class, make sure you kind of initialize all the static variables first, which I forgot to do, right? Let's now do it. So this static variable here is going to be initialized to be 1. So let's set aside a box. Let me put it here. So to make sure it's really global, right? So this is a counter here. And then this is not really an object. So it's going to be global counter. I'm going to say GC, global counter. And I put a star here. It's a static. Only a single copy. And its initial value will be just 1. Right? I should do that first. But if you forgot, that's OK. Just remember to put it back. All right, and then let's go back to the first object creation. So here, let's now trace it very carefully. We're now stepping into the account constructor, and then how about this line here? This line is telling me this .id should be copying the value for the global counter, which is 1 right now. So I'm going to put 1 here. And then I'm going to increment the global counter here so that it's visible to all the account objects, specifically the next one that's going to be created. So they're going to use 2 instead of 1. All right? And let's do the second one. Yeah, of course, you can put Jim here too. All right, the second one. Let's say account number 2, right? So ACC2 is going to point to also an account object here. And that one there, what's going to happen to the ID, right? So we're going to step into the account constructor over here the second time. What's going to happen when we execute this line here? This.id, this will be replaced by ACC2, right? ACC2.id will be global counter. What's global counter right now? 2, right? So copy 2 over. And then the second line here, we're going to increment the global counter by 1. Increment it by 1, so it's 3. But you can see it's kind of nicely just keep incrementing. It's guaranteed every account ID that you create is going to be unique, starting from 1 until maybe 2 to the power 32, right? Something like that. And owner here will be Jeremy. And finally, if you want to do some very simple check, ACC1.id, ACC2.id, are they the same? They're not the same, which is good, right? They're unique. That's what we intend to do. All right, any question about this? So this will be the correct usage of the static keyword. Everyone's good for this? Good. All right. Let's now consider one suggestion made by the morning session, your classmate. Okay? And to really let you get the most out of it, let me create a new page and show you the question. Basically the same example, except I want to add a single word. What's going to happen when I say this integer counter, this integer ID here is also static? That's the change. Well, I can tell you right away it's wrong, because it doesn't really comply with the standard pattern that I just showed to you. It's wrong. But what you really want to dive deeper is, it's not going to be a true-false question for you in the test. Either it's right or wrong. Too easy. What I really want you to understand is, how wrong is this? All right? I'm going to trace together with you. I'm going to do that. But can you guys please just spend 1 minute, right? Think to yourself, if I try to execute the same lines of code over here, what's going to happen? Given that this used to be non-static variable has now been static, what's going to happen? Why would I say that's wrong? Think about it. You can imagine in your mind where you want to grab a piece of paper to draw it, up to you, but thinking about it might just be enough. If you have no clue, that's okay. You know, maybe you haven't done enough practice, but I can tell you, this kind of introducing some variance to some solution is important. You always want to be very open-minded about different solution and being critical about whether it's right or wrong. That's a very important lesson to learn, which we'll do throughout the course. Anybody want to share their thoughts quickly? And I'll take one if you don't mind, okay, in the interest of time. How about you first? Okay. Okay, so you're claiming that somehow every account we are going to create is going to have the same ID rather than unique ID somehow. I tend to agree, but why don't we try to trace the code together to make sure everybody's convinced? Okay? Let's now take a look. So now we have only one non-static variable left for the class, only one, right? But before I do any tracing, let's do the good practice. Why don't we try to set aside a box for the counter class? And then I'm going to put all the static or global variables over there. In this case, we got two. We got this one here, and also we got this one here, right? So we got GC, and also we got ID. Both of them. And if you like, you put a star here just to indicate they are global. Initial value for global counter is just 1. And for ID here, it was not really initialized explicitly. It was just default value, 0. Okay? Good. And let's now try to trace it. You know, actually, if you get this initial step right by including both of them in the same box, indicating global variable, I would say you're almost 50% correct, almost. Okay? The rest will be just to trace the code and modify the diagram accordingly. Let's see. Line number 1. Okay, we're still creating EECS2030E, which is going to be an account object. But now, how many attributes should we put over here? That's the question. How many should we put? 3 or 2 or 1 or 0? Or 4? 1? Which one? I agree, just owner, exactly. How do you judge? You have to see which ones are non-static, which is this one here. That's the only one. Good, very nice. All right, so we're going to put owner here. And then let me copy this one. I just need it once more. All right, for this particular one, it's going to initialize Jim, right? Yeah, somehow I'm cheating a little bit. I'm just executing this line first, but you see my point. Let's now get to this one and this one, right? Let's see. Now we're stepping into the account constructor here. What about this line? This.id, and notice that this.id, even though it's going to be ACC1.id, but it's not referring to anything specific to ACC1. It's referring to this global one. Agree? So now when we say this.id equals global counter, you're basically saying, let this one here be reassigned to what this value is. That's what it does. Okay? And then we say that global counter plus plus, increment this from 1 to 2. At this point, if I say ACC1.id, what will be the value? ACC1.id? 1. Okay? Remember this one. All right? Let's now try the second one. All right? ACC2 is going to point to an account object here. And let me just change its color. And it's going to be Jeremy. Let me just set it up first. Jeremy. And let's now try to step into the account constructor once more, second time. So what about this line here? So basically, it's going to be ACC2.id, but it's still referring to this ID here. Doesn't matter. It's a shared copy, but it's static. So now I'm saying ACC2.id will be the global counter, which would be 2. Right? Copy this value here into this. So this will be 2. And when I get to the second line here, global counter plus plus, I'm going to update this one to be 3. I hope you already can see how ridiculous this solution is. Because now, if we, let's say after this line here, if I try to ask the following. What's ACC2.id? Number 1. What's that? 2. Doesn't seem to be bad, but if I re-ask you the question, ACC1.id, what is that? Also 2, because still referring to this. I hope you see how wrong this is. It used to be ID1, it's now ID2. That's wrong. All right, so that's one example where we can modify our solution here and see how the consequent behavior should look like. That's some skill you want to pick up too. And you got all the skill you were taught. Basically, you want to know how to trace the code, visualize them, and then it should be good to answer the question. All right, I got 2 more, and then let's do 2 more, and then we'll take a short break. Okay, 2 more. Any question about this one here? Yes? Correct. So thinking this way, because the ID here is declared to be static, there's only a single copy here, no matter what, just a single one. When I say ACC.ID1 here, I'm really referring to this memory location. When I say ACC.ID here, I'm still referring to the same location. But the thing is, in between, I actually increment the global counter and copy that over already. So ID has been changed all the way to 2. So that's why, even though you're referring to the same location here, but its value has been changed from 1 to 2. But it shouldn't, because the ID should be a local one to the object itself, not global one. So when you use a static, like here, the ID is no longer a specific copy to each individual object, as you can see, right? Because the ID here is now a global one. Whenever you change the ID here to whatever value, it's going to be visible to all the existing objects of the same kind account. Yes, that's correct. So if you go back to the previous correct solution, we actually don't have the static for the ID. So you really want to contrast these 2 solutions here to see why one is correct, the other one is not. Okay, good. All right, if no question here, let's do a second example about static. The second example here, I want you to, right, so if you look at the slides, I've set everything on the slides. I don't need to read it over. Please read it over yourself. This one here, all right? Stare at this piece of code for 1 minute. That one should somehow seem familiar to you because you have seen that in the programming pattern, except there's one single change. Can you notice the change? I'm sure you can. I highlighted it, right? Static. Take a look. All right, so nothing should be too strange. We got the array. You can think about the client here is more like an account collector. And again, we got an integer counter here, number of account, NOA. So we declare it to be static, which is different from what you saw in Lab 0 Part 2, and also in the written notes. And the add account method is just the same. I can tell you this method has no problem. Method itself has no problem. Question number 1, is this piece of code correct or not? Most likely not, because that one's different from what we studied before, right? Because I have added static keyword over here. So now the number of accounts is no longer it's no longer an instance-specific value for each client objects. Instead, it's going to be shared by all the client objects. Okay, I already answered for you for number 1, it's wrong. Number 2, how wrong is that? That's a question. I'll give you guys maybe 1 more minute. I think it's really important for you to at least try to think about, right? So that's the class. Static is the only new change we introduced. And now I got pretty much the same setup as before. Create client objects, create account objects, and try to add the account into the clients, right? Now, spend 1 minute. Can you kind of see how wrong this implementation is by changing the number of accounts counter from non-static into static? And we'll trace it together. I can tell you that when I first taught this example here, I didn't really intend to use this one. It's because I made a typo in my solution to the students about adding static. So that's why the solution was completely wrong, of course, and then I studied a bit about my error, and I thought, oh, this will be a nice exam question. So that's what I did. So now I put it in the material here. But I think it's nice for you to really see, by changing something from non-static to static, or vice versa, you want to know what kind of consequence you have created. I think that's really valuable for you to know. All right, anybody want to contribute their thoughts before I trace the code for you? In addition to you, anybody else want to speak up? Okay, if you're still thinking, that's okay. How about we let him try? Go ahead.
So since it's static, the number of accounts is going to be like the current number. So it's always going to refer to the last account, which is Steve's.
Always going to refer to the last account, but that one is kind of telling you how many account has been stored so far, right? But when you say referring to Steve, what do you mean, referring to Steve?
Because Steve is the last account that was added, so it's always referring to like this. In this case, it's the second one. So
Second one. You might be getting somewhere, but not exactly precise, not accurate. But thanks for trying. Okay, how about last one? And then we'll move on. Yes, go ahead. What's wrong?
Oh, well, I was going to say, since the class is based on client,
Yeah,
the number would go up every time you make a new account for every client.
yeah.
For example, Steve only has one account, but it will return that it has two accounts.
Okay, that's very good. Yes, I think you're on the right track. Okay, but that's something that will also be obvious when I trace the code. Very good. Guys, thinking this way. This is global. After this and after this, it's going to be incremented twice. That means this value here will be 2. Let's say we create another account, let's say Tom. And I ask Tom dot number of accounts. It's going to tell me 2. But Tom is just created. How can he have 2 accounts? That's basically what your classmate said, which is completely right. All right, hold that thoughts here. Let me show you another concrete example. Okay, let's say here. Let's try. Let's now try. I'm going to trace 1, 2, 3, 1, 2, 3, 4 together, right? So Bill is going to be a client object. So Bill is pointing to some client's objects over here. And of course, I should have set up some box away for the static. So you can think about the client has some global variable here, in this case just 1. Client. It's static, so I would say that is number of accounts, NOA. Initially, it has the value 0. Okay, that's something I should have done first. This one here is corresponding to this one over here in the beginning. And then, let's now try to trace other parts. What about, okay, for Bill here, it's going to be creating accounts. Let's make the assumption. Let's say it's going to create the account of certain size, right? So this is the only non-static variable, ACCS, standing for accounts. It's pointing to some array of certain size. The size here is not really the point. But let me say 0, 1, etc. That's good enough. And if I go to the next line, Steve, okay? Similar. Steve pointing to some client objects. That one there has a separate array because it is non-static. That one there is pointing to another array, 0, 1, right here. Right, so that's after these 2 lines. And we got ACC1, ACC2. Right, let's create them. ACC1 is pointing to some account object here. ACC2 is pointing to some account object over here. So now I just want to see how the objects are being copied its address to. So the contents here doesn't really matter for the tracing. Let's now do this line. Okay? When I say Bill.add account, I'm calling add account for the first time. So ACC will be ACC1. right? Bill is going to replace every occurrence of this. All right? So what this will do is current value for number of accounts is 0. That means I'm going to store an index 0 for Bill. That one there should really point to ACC1. And this one is something we covered already, right, in the review tutorial. And then when we say bill.number of accounts plus plus, we're basically saying 0 to 1. I'm not sure if you already see the consequence of this. What's going to happen when we do the second one, Steve.add account? Which NOA are we going to start with? 1, not 0 anymore, right? If you still cannot see it, let's see. So now let's try this. Steve.add account, a different context objects. So we say here, Steve is the context object, and we are tracing this method step into it the second time, And then every occurrence of this is replaced by Steve. And this will be replaced by Steve. And we got ACC2, right? So ACC will be ACC2. So now, accounts for Steve. Which index should we go to? Corresponding to the value for number of accounts, which is here. Not 0 anymore, it's 1. So that means we're going to store here, index 1 is now going to point to where ACC2 is pointing to. And then the next line, we're going to increment this global counter by another 1 to 2. And how bad is that? You can see from what we have got so far, you can see this slot here is unused. It's wasted, right? It's not even used. Because the counter, whenever it's incremented, is visible to all the existing account objects. Now you want to imagine that if I try to call this add account 100 times, this value here is going to be incremented all the way to 100. And I do one more add account. Which index is it going to start storing for that one? 100. So from 0 to 99, they are all unused. That's bad. So what you want to think about is, if I say bill dot add account, okay, you put some account object here, right? And the same for, let's say, 99 times. Try this in Eclipse. So that's the first part I want you to try. And the second part, let's say after 100 times adding account to the bill, I want you to now add to Steve. After this, if I say Steve dot add account. Now, how bad is that for Steve? Right? You want to use a debugger and see which slots in Steve's accounts array is going to be null. It's going to be lots of them because your counter is going to start in the wrong place. All right? Think about this one here. Any question about this? Right, so far we have seen 2 examples where the variable was mistakenly declared as static. And the non-static should be the solution. But sometimes it could be that the variable should be static, but I gave you a non-static version, in which case, what should you do? Trace the code and see what's wrong. Okay, one more, and then we should take a break. Just one more, please. Okay, so the last one here is going to be about nothing to really trace about, but it's a common error you also see on the IDE. Oh, this one here. Okay, this will be a piece of code. Oh, let me just go over that together quickly. Okay, here. So we have a class called bank. And we got some non-static variable, branch name. We have some static variable called next account number, initialized to be 0. So this will be non-static, and this will be static, so that you can see very clearly. And what we have is some method implementation here for the static method. We say next account number plus plus. It's almost like incrementing the global counter. And then what we want to return is this concatenation between this and this. All right? And let me number them. This one and this one. Line number 6 and line number 7. Okay, let me save some time by directly challenging you. This piece of code over here contains some compilation error. Is it line number 6 or line number 7? I'll make it very focused for you. The way to think about this, let me give you a little bit of hints. It's really important for you to think it through yourself. You want to think in this way. In order for me to call this method over here that's being static, the way you call static method will be the same as you call static variable. You can say class name dot the name, right? The way I can expect to use this one here, is it going to cause some trouble to this line here or this line here? That's how you want to think about it. Let me be more explicit. The fact that this is static method here, you can note to yourself, number 1, the expected usage. Will be class name dot get info. Static. And one thing to note, there's no context objects. That's how you should start with. Is this expectation here going to cause trouble to this line here or this line here? That's the question. Anybody? 6 or 7? That means 7, right? Okay, good. 7? Why? It's not a static variable, I agree. You can see the branch name as line number 7, you're saying this, the branch name. This, what we're expecting here, is not something like a bank, the class name. We're expecting something different, right? All right, let me now give you guys some ideas. You can think about it. Oh, by the way, this is something you may have seen before in the first year. Non-static method cannot be referenced in a static context. Have you ever seen this before? Okay, maybe you have, but you have no idea. Well, if you know about what that really means, that's good. But if you have no idea, now you know. Whenever you want to refer something that's non-static inside something that's static, then you got trouble. Okay? Let's now take a look over here. So what we want to think about is this. We know that when we try to use this method here, we can use the class name. However, you can see that this line over here, this branch name, the this specifically should be replaced conceptually, right, when you trace the code, by some objects. For example, if I say, let's say bank CIBC, for example, new bank. Now, if I say CIBC dot branch name, this will be a proper usage, right? Because you can see here, the CIBC is a proper usage for this, right? It's a proper replacement. But that's not what we have right now. Because the way you can call this static method is by using bank.getInfo. If you simply replace bank for this, is it going to work? Not really, because branch name is declared to be non-static. You can use it. You cannot use it that way. Okay, this would mean if you got bank dot branch name, this is not good because branch name is non-static. Okay, that's something you really want to draw your attention to and think about it. The bank over here and the this over here. If you look at the slides, I also try to write down more nicely, but I'm not just trying to visualize it to you what the issue is. How do we fix this? Final point. How do we fix this? There are two ways to fix this. I'll mention both. You tell me which way might make slightly more sense to you. All right. Okay. Since I say two fixes, right? So why don't I get two duplicates here so you can see both fixes side by side. Okay. Fix number one. We know that by referring to this particular non-static variable is problematic in the static method. Just get rid of it. Just don't use it. That's solution number one. All right? Solution number two. Go the other direction. I know that the reason that I cannot refer to this variable here is because currently it is static. I can only refer to static variable inside static method. So why don't I just make the branch name over here static? That's the second fix. So either solution is going to make sure in this particular static method, you only refer to static variable, either by removing the non-static or by making the non-static static. Either way. Now, any criticism about fix number two? It will work programmatically, but does it make real sense to make the branch name static? How come? No. Yeah, exactly. You might have a branch in Scarborough, have a branch in Newmarket, etc. Right? There should be instance-specific attributes, right? So it doesn't make sense. It's a poor fix as far as design concerned. Not ideal because each bank object should have a different branch name. All right. Any question? Yes.
So beside that,
Yeah.
also adding this
Yeah.
feature.
Uh-huh.
So
Oh, okay. You might be thinking that's something wrong, right? No, that's nothing wrong with that. By the way, okay, I'm glad you asked. You might run into that in the lab anyway. Can you concatenate an integer with a string? Unfortunately, you can, which I don't quite like how they deal with this in Java. I think that should be an error conceptually, but you can do it. I'll show you. If I try, this is an aside. Let's say 23 plus 46, for example. If you try that, S equals, okay? Now, what's going to be S for that? It's going to somehow treat both of them as string. This will take precedence, okay? So it's going to be 23, 4, 6. Give a try on your Eclipse. That's something worth noting, okay? All right, any more question about review? We are done. Every point I think you should know for review. Yes?
Why even have a static
Oh, here just for illustration, just to say, for here I want to show you a method where you don't really need to create any context objects for calling the method. You can just say class name and then method. Yeah, for this course, you don't really use static method that much, but I'm just showing you the possibility. All right, if no question here, why don't we say the following? Yeah, so you can now go all the way to the slides. How about we do the following, okay? Let me just go for only 2 or 3 minutes of lecture, and then I'll take attendance. And that'll be it. How about that? Okay? Because if we take attendance first, it might be a little bit harder to resume the lecture. Why don't we just cover 2 minutes? What I want to talk about is this. The exceptions lecture. I want you to, before Thursday, to understand yourself better about caller versus callee, these two. All right? Whenever you have a method call, for example, over here, o.m2, as soon as you see a line like this, you can already identify who is the caller and who is the callee. These will be the two terms I have to use very often when we introduce a topic for exception. Let me use 2 minutes to tell you something, and then make sure you review it before Thursday. Right? You can read this one. I can review that maybe on Thursday, but you can read this one for later. Let's say this. Right now, we are having a method call, M2. And the context object here was declared to be C2. So to really make the context complete, we'll say C2, M2, over here, the class name and the method name here. We say C2. And by the way, don't be confused about C2.M2. I'm not saying M2 is static, okay? I'm just using a way to say the context for class name and also method name. C2M2 that's being called is called callee. All right? On the other hand, where are they being called? The context where they are being called is called caller. C1 and 1 is where this method call occurs. So this is the calling context. It's called caller. Don't overthink it. Caller is basically somebody who calls somebody else. In this way, in this case, M1 is calling M2. That's why M1 is a caller. Callee is somebody who's being called by somebody else. In this case, M2 is being called in the context of M1, right? So that's why M2 is a callee. And I want you to think about before Thursday. So this is the caller here, and this is a callee. Now, think about this question. Can a method be a caller and callee at the same time? Yes or no? First. And second, can you, if you believe that's yes, if you believe that's no, why not? If you believe it's yes, can you show me one example where a method is actually caller and callee at the same time? You can answer me on Thursday if you got the answer, okay? All right, so guys, one thing you should do before Thursday, please make sure you understand these two, all right? And then think about this exercise. Let's now do attendance check. Have your device ready, please.